So, hello everyone, and welcome to our session, Life Hacking Cloud Architectures. Before we start, a few words about ourselves. Thorsten and myself are consultants at Novatic Consulting Company, and since our main work lies around cloud architectures, we are, of course, very interested in securing those cloud architectures. Our employer, Novatic, is a consulting company with around 400 employees. And what we do is modern software development, technical enablement, agile methodology consulting, trainings, and much more. So we have a booth outside. Come and meet us and have the chance to win AirPods Pro. And discuss any questions if you have any. Well, we prepared something for you today, and it's important to mention that it's not totally made up. So it's based on real-world use cases that we face in our daily job. We have a company in the financial sector. It's called Never Victim Consult. And they claim to protect you against cryptocurrency heists. They did a great step. They moved to cloud. They talked about it, which is also very good. However, that's how they caught our attention. We read their blog posts. We had a look on some technologies and tools they used. And even better, we were able to meet their DevOps team, who's responsible for that. And with that information, let's meet them. Let's play around a little bit with their cloud architecture. And with that, I'll give the word to our attacker, Thorsten.
Hello. So I'm interested in to find out some more information about Never Victim Consult. And to do so, I'm using their domain to grab some information. So we're going to do a DNS enumeration in order to find out how is their domain look like. We recognize they are using Google Cloud DNS service, which is interesting to know for us. Maybe they do more things with Google Cloud, but by recognizing this, we also have a problem because Google Cloud DNS prevents our Never Victim Consult for a so-called zone transfer. By doing a zone transfer, I would get all information about that domain, all IP addresses, all subdomains. That would be very cool, but unfortunately, that does not work with Google Cloud DNS. So I need to do something different. I'm going to do a brute force attack on that particular domain. So I'm using a word list. The word list, which is containing out of the 5,000 mostly used subdomains, like dev, prod, social, API, you name it, right? And my tool using that list is already finding some information here. So we see they do have a mail server. They probably use Office 365. They have a Git, and they have a Jenkins. Right, having a Jenkins is interesting for us. So I want to find out some more information about Jenkins. Raise your hands if you know Metasploit. Good. So Metasploit is a framework coming with many tools for penetration testing. So I'm going to use a tool, a plugin in Metasploit to find about which version they are using. So that's a auxiliary scanner for HTTP-based applications. And I want to set a remote host to Jenkins. Jenkins.test. And now let's see. We now know that they're using Jenkins in that, well, particular quite modern version, which is not good for us. That would take some more time to find a good exploit, right? So fortunately for Never Victim Consult, interesting endpoints are already protected. So I need to find another way to get access to the Jenkins. I'm interested in the Jenkins, so getting access is crucial for me. So I'm going to do another brute force attack in order to find a valid username password combination. That will take some time. Let me prepare that. So the port is, oh well, that takes too long. The port is 80. And I need to set the login URL to the Spring security check. That's the default value. If you have a more sophisticated installation of Jenkins, you would expect ping access as a security check, for example. So we are setting stop on success. We only want one valid combination. And now the problem is I don't know usernames, I don't know passwords. So fortunately I prepared something. You remember that blog post that Mirna just showed? So we know some names, right? So let's use that. So I prepared a username list and a password list. So the password list consists out of 32 million leaked passwords. That's the so-called ROCU list. And there's a fair chance that somebody is using that particular password. I know that there's a guy called Jeffrey van der Linden working at Never Victim Consult, and I used a tool to generate typical username patterns, right? And fortunately, Jeffrey is using a password. Well, that password list also consists with entries like admin, admin, right? So default values are also in that list. So I have a successful login here. And then I would say, let's try to get access to that Jenkins. Who feels uncomfortable right now? Except me. So that's Jeffrey van der Linden and the password. No. There it is. I have access to Never Victim Consult's Jenkins, and by looking at it, I recognize there's a CI job, so they're building software with it. That's interesting. They probably deploy it somewhere. I recognize I'm not alone at Jenkins, it's in use, so I need to behave a bit cautious. And there's an infrastructure job. That's interesting. So probably they're using something like infrastructure as code, Terraform. They're using Google Cloud. So we know that they're using Google Cloud. So probably they have some credentials to deploy or provision their cloud side. There's a plugin in Jenkins, the credentials plugin, used to store credentials. And we can recognize that they also have, like everybody all in this room, a hard time to maintain Jenkins plugins. So credentials plugin, and we see credentials. Well, that's cool. And as I guessed, well, there's a kubeconfig, there's a Redis, and there's a service account for Google Cloud. I would really like to have that one. Well, unfortunately, I cannot see it here, right? That's a problem. Let me show you a solution to that problem. That's an encrypted string. That string is encrypted by a key that is signed by Jenkins. I don't have that key, so decrypting that string with my notebook would take some more minutes or hours in order to get to guess the key. That's possible. That's really possible, but I have a better idea. Since I can access the credentials plugin, I can ask Jenkins to decrypt it string for me. Oh, well, that's Hudson. So I hope there's no typo. What's that? That looks like, well, it's maybe a secret. Secrets are usually encoded with base 64. And since this is a quite long string, I guess this is a login JSON for Google Cloud, because Google Cloud expects JSONs for login formats. So let's try to decrypt, to decode that decrypted string. I copy that to my shell here, and using that one, which enables you to see it a bit more. So there's that string, and I now will use base 64, decode, and bring it into a JSON file. So I just stole that. Well, even if you watch the recording, you will not be able to use that string after this talk, because the site will be destroyed. But well, let's try to get access to Google Cloud with that string, and it seems that it contains a service account, and now we will use and as you can see, Jenkins test. Well, that's a service account, and that's what we are looking for. Well, that's one. So it seems we are authenticated and also authorized against the Google Cloud API. Let's see what's there. Storage. Oh, well. Container clusters list. We do have access to 2 Kubernetes clusters. Let's see. If we can, well, we do have now a running kube config. That's good. And with that running kube config, we will try to look a bit around in that Kubernetes cluster. So we are going to use a tool called Octant, which makes it a bit more easy to browse around. And we can see that there are some namespaces. Well, that's probably customer data, which is interesting. There's a tool chain with my friend Jenkins here, so that Jenkins is also running in the cluster. And there's something what I don't know. I couldn't do the app. What app looks interesting, maybe that's the thing that they're building with the Jenkins. And there are deployments and backend containers. Containers with database credentials, with a prod profile, and with a working terminal, right? So with an application jar. So I could maybe replace that jar with something that suits me a bit more. Can I do that? Since I'm root, I can do that. So I don't have an idea what Conduit backend is doing. So I need some more time to find out about that. So I have a very good idea. I would really like to have all the traffic that is coming to that application and send it to my VM to enable me for a bit more analysis. So what can I do here is putting a sidecar container to my deployment in order to stream all the traffic on a TCP level to a VM. So maybe somebody will know, somebody may not know. So I'm going to edit that deployment, and hopefully they don't observe it. And I guess they not, since the access was quite easy. Right? So no typo at least. And as you can see on the right side, containers are quickly restarting. And now I do have 2 ready containers. And I can now spawn into my sidecar. And that sidecar is capturing traffic and send it to my site. And now I will take a break and look around what they are doing. Drink water.
Drink
yeah.
water.
You want to clap? Yeah, okay, you want to clap.
So, what did we see till now? We saw a red team trying to attack the cloud architecture of Never Victim Consult. Maybe the attacker was lucky to find those credentials into Jenkins, brute forcing Jenkins. However, there are also many different ways, maybe more sophisticated ways, just as examples, the GrooveScript console, the Metasploit Metabreta session, and many others. And to recap that, the attacker started with a reconnaissance phase. He gathered some information about the domain of the company. He recognized they are using Station, they have Jenkins. Then he was lucky to brute force Jenkins on the test environment. He got access to Jenkins, and then he leaked the service account key and was able to access their cloud Google account. And then on their Google Cloud, sorry, I messed it up, their Google Cloud, and then he had a lock around, and he discovered they are using Kubernetes. He accessed their Kubernetes cluster, and he tried to inject a sidecar container in order to capture all the TCP traffic on the pod's network interface level and send it somewhere else to analyze it and make use of it later on. He also found out that they're using cloud storage. They have some database backups. He could also download that and make use of it. And now, let's assume I'm the head of security at Never Victim Consult. I noticed some strange behaviors on the test environment. There were some increased egress costs of the traffic leaving the cluster. There were some downtimes when rolling updates, the Kubernetes deployments. So I was pretty sure there's something going on the test environment. And I assumed that the attacker will come back and will try some stuff on the prod environment. So I decided to take some actions. And guess what's the first thing I've done? I've asked all the employees to change their passwords, of course. And then I deployed Ingress in order to log all the traffics in front of all the internet-facing applications. I also made use of some security and observability tools. And having that said, I used Tetragon. How many of you already heard of Tetragon or maybe used it? Okay, only a few. So Tetragon is a security, observability, and runtime enforcement tool developed by Cillium. It's based on the eBPF language, and it's Kubernetes aware, so it understands all the Kubernetes identities and objects. And it enables you to define and apply some policies on the operating system kernel level at runtime. By default, it logs all the process execution and termination events. However, you can extend that using the so-called tracing policy custom resource definition in order to hook into any kernel function or system call, trace some security events, and do some actions based on a match. So here, for example, I deployed a tracing policy using Tetragon, and I worked on the kernel function level. I used the fd install kernel function, which is triggered whenever a file descriptor is installed into the process file descriptor table. So whenever you do any I/O operation with a file. And I said whenever this binary TCP dump tries to call that kernel function, I want to kill the process and prevent it from continuing. There are also other ways to implement that. For example, we could work on the system call level and prevent the process from continuing even before it starts working with any files, and say whenever it tries to execute using that system call here, prevent it and kill the process. And now, let's try to see that in action. So, the attacker will come back and try to do exactly the same on the test environment, on the broad environment, sorry, this time. However, this time, we said we have ingress to log the traffic. So, let's see. Let's have a look on the logs of ingress there. Using the logs of the bot. Well, copying and pasting with being a little bit nervous is not that easy, sorry. So.
Don't worry, I'm still attacking. Right.
Okay, great. And now let's see. Well, this time we're getting all the login attempts with, and in the real world, this should be connected to a SIEM, a system information and event management system, where we gather all the information from the different resources. We get notified about such security threats, and here we could react directly. We could send the attacker, for example, to a honeypot to gain some time to analyze or have some more information. We could block their IP address. We could do some stuff. However, for the purpose of this talk, let's let the attacker continue. And now the attacker will try to do the same with injecting the sidecar container into that backend bot. However, let's see what will happen when the attacker tries to do that this time. So let's watch the bots of the backend, and let's also, on the other side, get the logs of Tetragon, of all the Tetragon bots and all the worker nodes in a compacted way. Tetragon also supports other outputs like JSON, for example, but it's easier for us to see that in the demo right now. So let's also start that. And now the attacker will try to inject the container.
Oh yeah.
So let's see how fast this will go. Dear attacker, are you sure that you did that on the broad environment?
The attacker takes a moment.
Okay. Okay. There's something going on. We can see there's an error. The bots are crashing. And in the tetragon logs, we should also get that the process is being killed because we deployed that tracing policy. Here we go. Now we can see it. There's a sick kill sent because we deployed that tracing policy to prevent the process from continuing. So this was just an example how the things could be done. It could be also much more sophisticated to prevent a lot of stuff. And
Hold on.
Yeah. Just to wrap it up, again, the attacker came, tried to do exactly the same on the broad environment, started also with the reconnaissance phase of exploring their domain, and he wanted also to try to brute force Jenkins. However, this time, we could get all the login attempts because we deploy something that helps us to log all the traffic in front of the application, in this case, in front of Jenkins. And like we said, we could react directly. This time we let the attacker continue. And then the attacker got access also to the Google Cloud, tried to do the same with the Kubernetes cluster, tried to inject that side container to capture all the TCP traffic. However, this time he was not able to do that since Tetragon sent a sick kill directly and killed the process. And with that, we can say that observability is not a security silver bullet, however, it's a paramount. And with that, I want to say thank you so much for your listening. And do you have any questions? That was pretty fast.
That was pretty fast. Exhausting.
It's great that it's a little fast because then we have some time for questions. And we have a couple of questions. Thank you for putting in some questions. Which one do we want to start with? Oh, I just removed one. I didn't want to remove that one. If it was yours, please put it again. So sorry. Is there a default policy rule set in Tetragon?
Oh, that's yours. You spent hours.
Default policy rule set?
Is it opinionated?
I'm not sure what's meant with that exactly. I'm not aware of any default tracing policies there. However, as I said, the Tetragon logs by default all the process execution and termination events. However, you can extend that and access any kernel probes, trace points, and recently they also supported the user probes level. So you can hook into any system call or kernel function to trace different arbitrary security events there.
Excellent. I was able to retrieve the question, but I think it's very similar to the one that you have just answered. So let's move on. I'm approving all of your questions. Thank you so much for all of your questions. You're a wonderful audience. And just before lunch, too, you have so many questions. Fantastic. All right. Did they really brute force such a complex password? Question?
Yeah, sure.
Yes, sure. Yes, sure.
Well, just Google for the Rockio list. And well, what an attacker definitely has is time. So brute forcing 32 million, that was just one threat, right? You can increase the threats, having also attacking on various sites so that you speed up a bit. So brute forcing such complex passwords with a share on the Rockio list is, well, pretty obvious.
Great, thank you. There was a good one here. Do you have any recommended go-to tools for penetration testing in Kubernetes?
Yeah, recommend go-to tools. Well, not really. Since there are many tools upcoming and still going to the market, like, well, we do have Aqua here. They have Aqua booth here. Go and ask them. Well, they really provide strong tools. And there are other companies who are providing that. So I would definitely recommend them. I really like to use all the tools from Sysdig in order to have some presentation testing. Well, the frameworks change, the methodology is the same. Go and ask them. They really do have good advices, I guess.
Excellent, and they're here, no? So
they're here, yeah.
That's smart. You just offloaded that to
right.
to other people. Okay, excellent. I'm gonna. Oh, actually, you can help me in choosing one more question. Is there anything there that tickles your fancy specifically? And otherwise, I'm just gonna grab one.
Well, Mirna, that rename thing. I know you spend a lot of time with that policy.
I'm gonna highlight it.
Would it be enough? Where is that? Would it be enough to rename TCP dump to escape the policy? Well, in this case, if you rename the process name, the binary name, yes. However, as I said, like here is just an example. We filtered on that argument name. However, there are also many different filters that you can define. You can work on the metadata level for the process itself and also for the Kubernetes object, the namespace, the pod, the names, etc. So yes, in this specific case, yes, but in general, not if you have really strong tracing policies.
All right, we do one more.
The best measure.
Is you have one that tickles your fancy? Yeah.
Well, the best measure from this attack, there have been various attacks. Well, the best thing is don't store credentials in Jenkins directly. Use a secret storage like Vault, Key Vault, whatever. But don't use the credentials plugin. And if you do, maintain the plugins, not like the admin on that particular one. Another question was about the one-time password thing. That would definitely be a really strong measure to protect from brute force logins. Don't use obvious usernames, and don't only use the Spring security check. Use strong options like ping access or whatever, right? So secure, if you're brave enough to secure a Jenkins, run a Jenkins in internet-facing environments, take it serious and don't use default installations. Well, and as Mirna said in the very beginning, it is not totally made up, right? So I think you recognize some things.
Cautionary tale. All right, thank you so much for your answers and for your talk. Let's give them one more round of applause and go into lunch.
Thank you.